Hey everyone, so this is going to be the review lesson for our first unit. Now, there weren't a lot of questions asked. Please ask questions, it helps me to figure out what I need to spend more time on. But since there weren't a lot of questions asked, I'm just pretty much going to go over exponents specifically. There were questions on exponents, so I'll spend a little bit more time with that. But otherwise, I'm just going to be going over this practice quiz. So, an industrial machine creates 4 to the 3 times 4 to the 5 products a year. How many products does the machine create each year? Okay, so what we're going to do here is we're going to look at our problem, which is 4 to the 3 times 4 to the 5. And we're just going to kind of remember our exponent rules here. So we have the same base and we're multiplying, which means that we're going to add, right? 4 to the 3 plus 5, that's essentially what that means, which is 4 to the 8. Now at this point, 4 to the 8 is probably going to be a really, really, really big number. So I know it's D because these are too small. So the answer is 65,536. Now you might be wondering, okay, but that doesn't really show your work. Yeah, it does. This is your work already. If I see this, you're completely done. Like, that's fine. I'm not expecting you to do like 4 times 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 4. That's too much. If you can use logic to get out of it, awesome. I love it when students use logic to get out of problems. It's completely fine. Just show a little bit of work to show how you got to that point. Okay, simplify the expression. This one is a little bit of a doozy, but again, this just comes down to your ability to use PEMDAS or GEMS, whichever one you like to use. So here we have 2 to the 2 to the 4 minus 7 minus 1 to the 9 over 6 plus 20 minus 17 to the 3 times 3 to the 8. So PEMDAS. First thing I'm going to do is I'm going to just deal with the insides, right? So this is 2 to the 2. This is 2 to the 2 to the 4. Now, if an exponent to an exponent pretty much just means multiplication. So this is 2 to the 2 times 4. That's what an exponent to an exponent means. You need to multiply. Minus 7 minus 1 is 6. So this is 6 to the 9 over 6 plus 20 minus 3 is 20 minus 17 is 3 to the 3 times 3 to the 8. Okay, so the parenthesis is done. Now I have to go to E, exponent. So I'm just going to use a bunch of my exponent rules. So this is 2 to the 2 times 4, that's 2 to the 8. Minus 6 to the 9 over 6 to the 1 is just oh wait, is that a 2? Yeah, I should have put a 2 there. Sorry about that. So 6 to the 9 over 6 to the 2, so that should be 6 to the 9 minus 2 plus 3 to the 3 times 3 to the 8 is 3 to the 3 plus 8. So remember, multiplication, same base, you're adding. Division, same base, you're subtracting. Exponent to another exponent, you're multiplying. Okay? You can have these you should have these in your notes by now, but if you don't, I really suggest that you do. So let's keep going. 2 to the 8 is, well, actually, I think we're done. Yeah. Oh, wait, no, I can still do this. 2 to the 8 minus 6 to the 7th plus 3 to the 11th, which I believe is H. Yeah, that's H. So there's number 2. What is the weight of the ostrich written in scientific notation? Okay, first let's write it in standard notation. If you're wondering what standard notation means, it pretty much just means the normal numbers you're looking at. So the numbers that you're familiar with, that's standard notation, like 27,000, 2,000. That's standard notation. So 343.92 So in order to turn this into a scientific notation, the first thing that I need to do, please have your notes ready, or pull up some notes or watch the previous video. I'm not going to write out the steps because there are in the scientific notation video. Just follow along if you can. First thing I'm going to do is I know that for scientific notation, my decimal has to be after the first non-zero. In this case, the first non-zero is 3. So I need to move this decimal from here to here. So now I have 3.4392. Ooh, that should be a 2. There we go. So that's the first step. The second step is to plop down a times 10. That's just all scientific notation has times 10. And the last part, I need to make my exponent depending on how I moved my decimal. So every time that I moved left, I need to plus 1, and every time that I move right, I need to minus 1. Since I moved 2 places to the left, that means that I have a positive 2, a plus 2 exponent. This is my final answer for the scientific notation. So just to break it down again, you need to move your decimal point to right next to the first non-zero. So that's what I did. I plopped down a times 10, and then my exponent depends on the direction and how many times I moved my decimal. So number 4. How many times as great as the weight of the polar bear is the weight of the African bush elephant? Okay, so that can be pretty confusing. So let's break it down. It says how many times as great as the weight of the polar bear as the weight of the bush elephant. That can be a little confusing because we're not dealing with numbers. But what if I asked you how many times as great as 6 is 12? So the answer to this, how many times as great as 6 is 12? It's still confusing. They're pretty much just saying how many times you need to multiply this to get this. The answer is 2. And the way that you would get that, so the answer to this would be 2. The way that you would get that is you do 12 divided by 6, which is 2. So what we're doing here is we're doing scientific notation division, which, if you don't remember, please refer to the scientific notation video. I will be talking about it, but I will not be writing it out because it is in one of the videos. So, African bush elephant, I have 27,000. Now I'm going to write this in scientific notation. If you don't know how to do that, I would rewatch the scientific notation video. But here we go. I'm just going to do it real quickly. So decimal's originally here. I have to move 1, 2, 3, 4. 2.7. And then I plop down the times 10. And then I moved 1, 2, 3, 4 times to the left. So that's positive 4. That's my scientific notation for the bush elephant. And then for the polar bear, I have 2,000. So I need to move the decimal 1, 2, 3. So now I have 2.0. Plop down the times 10. I move 3 places to the left, so that is times 3. So now I'm going to divide. I'm going to divide them. Move that there. Move that there. Put a line between them. Now, division is pretty straightforward. It's not easy, but it's very straightforward. You divide the left side, then you divide the right side. And then you just bring down this multiplication sign. So if I'll do this in orange and light blue. Sure. Okay, where's my pencil? There we go. So 2.7 divided by 2. Oops. That should not be a 6. It should be a 3. This is 6. So I just divided them. So I got 1.35. 10 to the 4 divided by 10 to the 3 is 10 to the 4 minus 3, which is 1. So this is my final answer. 1.35 times 10 to the 1. Cool. Don't worry about these. I'm not going to ask you about them. So here, a square section of the kitchen floor is made of 49 square tiles. How many tiles are on each side of the square section of the floor? So I have a square with 49 square tiles. Well, there's a reason why they're called perfect squares. They're called perfect squares because if you took the number, let's say, I don't know, 7 squared, essentially what you're saying is, if I have a square, I know that the area of this square is going to be length times width, but because squares are a specific kind of shape where the length and width are the same, essentially it's just going to be side times side because the sides are the same. If you haven't learned this, don't worry too much about it. You can kind of just ignore what I'm saying, but this is really important to know later on, especially for 8th grade. So we'll go over this more, but don't worry too much about it. So this is a is equal to s squared because it's side times side. So if my side here is 7 and my side here is 7, 7 times 7, 7 squared is going to give me my area. And 7 squared happens to be 49. Another way to think about this, if that was a little bit confusing, don't worry too much about it. I went a little bit ahead. It's going to come up in the next chapter or so, next couple chapters. But if that was confusing, don't worry. I'm going to spend more time on this later. But 49 tiles on a square floor, and I know that the tiles are going to be the same all the way across and all the way across. It's a 7x7 board. That one's more of a logic question than anything else. Or you could draw it out. Otherwise, it's mainly a logic question. Same thing with this. There's a giant cube with 1,331 cubes in it. So do this real quick. So I think it's about as good as my cubes are going to get. So there's a big cube with tiny cubes in it. Again, there is a reason why they are called perfect cubes. It's because you're multiplying. If you wanted to get the volume of this, you would do 11 times 11 times 11, which I'm pretty sure by 8th grade you should know volumes of a cube already. 11 cubed is 1,331. So the answer to this would be 11. Now, I know I told you to do your perfect cubes up to 10. Don't worry that you're not going to have a question. If you get a question, it's not going to go past 10. This was just an example. Again, this is a logic question, and it kind of lets you know where the term perfect cube and perfect square come from. I don't know. I don't think this is going to be on the quiz. I haven't written it in it yet. I'm probably not going to do it, but, you know, I would like for you to know where the terms come from. Okay, now time to something that's a little bit harder. The approximate value of an irrational square root. So right here we have 3. We know it's not a perfect square, but we can figure out to a certain degree what this answer should be close to. And the way we're going to do that is the square root of 3 is between 2 perfect squares. Almost every number is between 2 perfect squares. So I know it's between 1 and 4. If you have your perfect squares list, you should know this. So square root of 3 is between 1 and 4. Square root of 1 and square root of 4, which is 1 and 2. The square root of 4 is 2. The square root of 1 is 1. Now I just got to guess and check. I am guessing that my answer is going to be somewhere between 1 and 2 because square root of 3 is somewhere between the square root of 1 and square root of 4. Now, I know that 3 is closer to 4, so it's probably going to be closer to 2. It's going to be closer to this side. That's just a guess. You can honestly guess whatever you want, but this is just to make it easier on yourself. So I'm gonna pick, I don't know, 1.6 or 1.8. So let's try it. 1.8 times 1.8. 8 times 8 is 64. 8 times 1 is 8. Plus 6 is 14. 0, 1, 8, 4, 2, 3. 3.24. Way too big. So I gotta try again with 1.7. 7 times 1 is 7, plus 4 is 11. And then 0.7. So it's about 1.7. Right here I can stop because this is the only one with 1.7. In the test, I'm only going to make you do one decimal place, not two, for the sake of time, and I don't feel like torturing you. So one decimal place will be good enough. Okay. So that is essentially everything that you need to know, I think, in 8th grade Unit 1. If there are more questions that you have, feel free to ask me. I know that you don't start until 11 for tutoring hour, so hopefully you watch this beforehand. Otherwise, I will see you on Thursday, and good luck.